You can see the screen. Your mic is off. Your mic is off. You can see the screen. Okay. Today we'll solve some problems in circular motion. Okay, so try this first question. This is very basic. So how is omega related to theta? Your volume is now low. So omega and theta related. Your volume is not here. How do you relate omega and theta? It's d theta by d omega, right? Okay. And suppose instead of taking d theta by d theta, if I take delta theta by delta t, what is this quantity? Yeah. Average means some finite time interval. Instantaneous means infinitesimally small time interval. So from this we can get. So what is the answer? The first, right? So average from 1 to 2 seconds is theta at 2 seconds minus theta at 1 second divided by 2 minus 1. I have to find at 2 seconds, right? So at 2 seconds is 5. And average is theta at 2, that is 4, at 1 is 3. Oh. First 2 seconds means from 0, right? First 0 to 1 and then 1 to 2. So it should be from 0 to 1 second then. Between 0 seconds and 1 second, because first second is 0 to 1. And second is 0 to 1 and then 1 to 2. Your voice is very low. You're using what, laptop or this one mic? But its voice is very low. But
Now, is it fine, sir?
now it is fine. 2 square is 4.
Yeah.
So 7. At 0 seconds is 1. So it's 6, right? Okay, and the time interval is 2. So is it clear?
Yes, sir.
Okay, this one, let's go fast. Simple questions. Two particles having mass, capital M and small m are moving in a circular path with different radius, capital R and small r, with the time period are same when the ratio of angular velocity is. This was a very basic question.
It's
So,
same only.
yeah, you have to check how the time period is related to omega. You have to relate omega and the time period. What is the relation?
2 pi by omega equal to t.
Actually, this is the better way to remember. No, omega is how speed the angle is covered. So it will cover an angle of 2 pi in one time period. Okay.
Okay, sir.
This is a better way of remembering the formula. Omega is the angular speed, how far the angle is covered. It will cover an angle of 2 pi in time capital T.
Yes, sir.
Okay, so got the answer.
Yes, sir.
Okay. This one, two particles A and B moving in uniform circular motion, concentric circles. Okay, speed is given. Time period of rotation is same. The ratio of angular speed. So it's a simple question. Time period is same. Okay.
1:1 only.
Yeah, because time is 2 pi by omega. This one, the point on the rim of a disk starts circular motion from rest, and after time t, it gains an angular acceleration given by, okay, calculate the angular velocity. Okay, this is basic mathematical question. So, okay, start circular motion from rest means omega I is 0. Okay, and after time t, okay, and alpha is given as a function of time. You will find omega at 2 seconds. Okay, how is omega?
After 2 seconds.
After 2 seconds means 0 to 1, 1 to 2. So at 2, right? It's 2 plus,
Okay, sir.
2 plus delta. So the same as 2.
Okay, sir.
So how is omega and alpha related?
Omega is equal to integral of
This is the-
alpha.
Okay, here alpha is given. So okay, omega is integral alpha dt. So we can put the limits as 0 to 1. That will give us omega 2. Because omega 0 is 0. Right?
Yes, sir.
Got the answer?
Yes, sir.
Option.
Six.
Yeah,
Option
get
C.
option number, because in the exam you mark the option, no? So get used to telling the
Yes,
option. You can see. Okay, this one, the wheel of a motor rotates the constant acceleration. Okay, the thing here to note is usually the acceleration is uniform. Okay, here it's function of time. Okay, but still it doesn't matter because we are solving it from the basic. But the equations of motion like v equal to e plus at, all those things are valid for uniform acceleration.
Yes, sir. Constant acceleration.
Yeah, it's a different thing. The wheel of a motor rotates with constant. Okay, here it's constant. If the wheel starts from rest, again omega is 0. How many revolutions will make in the first 20 seconds? Yeah, do this one.
400 times, sir.
Okay. This one particle moves in a circle of radius. That's with the constant speed and period. This one the acceleration of particles. Okay. There's also a basic question. He said it's constant speed, right? So and it also says circle. So it's uniform circular motion. So for a time period of 0.2 seconds. So this time period means this is capital T. Okay.
Yes, sir.
Radius is given. So acceleration is what in terms of omega. Centripetal acceleration. That is the acceleration because for a particle moving in a circle, which is uniform circular motion, there is only one acceleration, which is towards the center. That is centripetal acceleration. How is it related to omega? And how is it related to v?
R square omega, sir.
No, omega square r, and then v is v square by r. Okay.
Okay, V equal to R omega.
One of them you have to remember v square by r, and then v is omega into r. Okay. So from this you will get this one, and omega is 2 pi by t. T is given, so get the answer.
Five, sir.
This one, the speed of a particle moving in a circle of radius r.
Sir, and R alpha only will be there, no, sir. That is for tangential acceleration or radial acceleration.
See, this is constant speed, no? The alpha is 0.
No, sir. One expression will be there, no, sir. R alpha.
Yeah. That is
What is for tangential or radial acceleration, sir?
that you can get from the units itself. This is what radian per second square, right? And this is
Yes,
meter.
sir.
So this combination is meter per second square. So this is tangential acceleration. But here in this particular case, it's and this is 0 because it's uniform circular motion.
Yes, sir.
Because alpha is 0. Alpha is 0 because its omega is constant. Okay. This is not applicable for this question. This one, the speed of a particle moving in a circle of radius 4 centimeters. Very quick time. As v equal to that, the t is in second, v is in minutes. Net acceleration. Yeah, here it's not uniform circular motion because velocity is increasing. The speed itself is not only the direction, even the magnitude of the velocity is increasing. Okay, so here you have to find the net acceleration. That is centripetal plus tangential. What the answer?
1 minute, sir. √2 4. Yes, sir.
4√2, right?
Yes, sir.
Option C. So centripetal acceleration is always v squared by r for a circular motion, whether it's uniform or non-uniform. Okay, but in the case of non-uniform circular motion, this thing will be there in addition. This thing comes from r alpha, and r into alpha is d omega by dt. and r is not changing, so I can take the r inside this d by dt, so it will become dv by dt. So this tangential acceleration is r alpha, right?
Yes, sir.
Alpha is d omega by dt. And this is a circular motion with where the radius is not changing. So r I can take it inside by d, inside this d by dt, so it will become velocity. Okay. Is it clear?
No, sir, I can't understand.
No. How did you find tangential acceleration?
D omega by dt.
D omega by dt. No, r into d omega by dt.
Yes, sir.
So this r is constant, no, for a circular motion.
Yes, sir.
Radius is no. So I can take this r inside this d by dt. Yes.
Okay.
Okay, then it will become d of r omega, that is dv by dt. Okay, this formula itself is enough.
Yes, sir.
Yeah. Okay, in the figure given, acceleration. Okay, so here there are two acceleration. One is centripetal, one is tangential, and then there will be acceleration in some direction. And this angle also you can find out. Actually, it's 45 degrees here because both are equal. Okay, but if it is different, we can find the angle as tan inverse vertical component AT by AC. Okay.
Yes, sir.
This one.
That 15 is net acceleration. Okay.
Yes, he has given a total. He has given the figure also. So from that we can do the centripetal acceleration and tangential. And centripetal acceleration, you can reduce the velocity.
Yes, sir. So 5 by 2 into root of 3 root 3.
Yeah, you have to do such calculation. You have to put root 3 as 1.732. So actually, v square will be 15 into 5 by 4, right? Into root 3.
Yes, sir.
So here I can take a 1.5. So v will become 5 by 2 into square root of 3 root 3. Is that right?
Yes, sir.
And 1.3 into 1.732 is approximately how much? 3 2 are 6, 3 3 are 9, 7 3 are 21, 2, 3 1 are 2. So square root of 516 into this 2 is there 2.5.
2.
Okay, 5 by 2 is there. Okay, so this 2 also I can take it inside as 4. So it become 5 into square root. If you take this as 4, 4 ones are 4, and then 11, 4 twos are 8, 39, 4 nines are 36. So square root of 1.2. So it's greater than 5. Okay, if it is exactly 5, okay, if it is 5.1 means we have to choose this one. So 1.2, square root of 1.2 is how much? I think 7. Am I doing some mistake? What is the number you are getting? Your mic is off. Sorry, I made a mistake here. This is 5 by 2, no? 2.5. No, it's correct only. 2.5, it comes, it will be 5 by 2. The mic is off.
Okay, sir.
So you're getting it as 5.7?
No, sir, I didn't do that calculation.
Yeah, I think you have to use root 3 as 1.732. Now square root of 1.732 is 0.866. No, that's also a standard number you have to remember. Root 3 is,
Okay.
root 3 is 1.732. Yeah, you just have to find b square, I think, not b, because b square 25 means this will come, and 5.7 square we can find out. So, no, anyway, it's complicated.
Oh my God, they're asking to 2016.
Okay, fine. Like a particle is moving along a circle of radius 25 with constant tangential acceleration to the velocity of particles at the end of second revolution after the motion has begun. Okay, this was a straightforward question only. Got the answer?
Sir?
Got the answer?
No, sir.
You know how to do, right? Alpha t is given.
Kinematic equation only, no, sir.
The velocity is at the end of second revolution. So 2 revolutions means I know the corresponding theta. I know the final velocity v. Okay, and r is known, so I know omega the final also. Okay, and starting from west, right?
But they didn't mention, no, sir.
Okay, particle is of radius constant tangential acceleration. at the end of second evolution after evolution has begun. So initially it's 0, starting from rest.
Okay.
So if you use p square equal to so got it.
1 minute, sir. 8 into t square will be 5.
So along the arc of the circle, it's like a straight line motion with uniform acceleration.
$160.
No, it's 40.
No.
So you have to use this v square equal to u square plus 2as, no?
I used s equal to ut plus half at square.
Uh,
U 0.
yeah, but how do you know time?
Time is a distance by your velocity. 4 pi r by 80, sir.
No, the velocity, it's not a uniform velocity, no?
Oh, okay. Sorry, okay.
See, this is a better relation to use. Because
Yes,
v is
sir.
known, u is known, s is known. You just have to find e.
Yes, sir.
It's a uniform acceleration, so velocity is changing.
So constant tangential acceleration only they have given, no, sir.
Yeah, acceleration is constant, but velocity is not constant. What is the centripetal acceleration means? That
We want to know final velocity only, no, sir. That is 80 only, no.
no, but how is time divided is equal to distance by final velocity?
Ah, yes, sir. Okay, okay.
It should be the average velocity.
Yes, sir.
So time will be distance divided by 40 then.
Yes, sir. Okay.
That's why you missed a factor of 4. So whenever B is known and U is known, this is a better equation to use because visibility UT plus half principal does not involve B. So the one equation which denotes both B and U is this one, B square U square plus 2AS. So here both U and B are known. So this is a better equation to use.
Yes, sir.
Got it? It's very simple.
Yes, sir.
Yeah, you have to say no. A particle is starting
Okay.
from rest, moves in a circle, radius r, it attains a velocity of v naught in nth round. Its angular acceleration will be. The particle is starting from rest, moves in a circle of radius r, attains a velocity of v naught in nth round. Its angular acceleration will be. So particle says so u is 0. Okay, so after traveling some amount of distance, yes, it attains a velocity of v naught. So this again is v square u square plus 2as that you can use because u is known, v is known, and ac is also known because he has given n rounds. Okay, so you can find the acceleration. I can say tangential acceleration. So it's same as the previous question.
2 years. 2 square by 4m by r square. Fourth option, sir. Option D.
This one. It is also very simple.
V square.
He's asking force. So you have to put mass into this.
mv square by r.
Okay, this is done. Okay, when the body moves in a constant speed along a circle. Okay, this is constant speed means uniform circular motion. The direction of the velocity is changing, but the magnitude of the velocity is constant. So no work is done on it. No acceleration is produced in it. Its velocity remains constant, no force acts on it. So which is the correct option? What is the answer?
Yes, sir. But can you please explain that the answer, sir? No work is done on it.
No, you cannot figure out. Okay, what about acceleration? Acceleration is there or not?
Yes, sir. Rest options I understood, sir. But option A, why is it?
Work done is what? F dot ds, no?
Yes, sir.
Okay, here F and ds are perpendicular.
F and DS.
F is radial, no? Centripetal acceleration.
Yes, sir. DS means?
ds is the displacement. That is perpendicular.
Okay.
That is tangential. And there is some centripetal force. So this angle is 90. So dot product of two perpendicular vectors is 0.
Okay. If the tangential force there means, then there won't. It is a non-zero only, no, sir.
Yeah. If tangential force is because this is uniform circular motion, no? So there is only radial force.
But in non-uniform, it will be non-zero.
Yeah, because
Okay.
tangential component of this thing will come. See, acceleration, centripetal acceleration means there is corresponding centripetal force. If there is a tangential acceleration, there is a corresponding tangential force. Okay, so this force will give work done because this and ds are in same direction, but this and ds are in perpendicular directions. Fc is perpendicular to ds, and ft is parallel to ds. So ft dot ds will contribute to the work done, but here ft is 0 because it's uniform circular motion.
Yes, sir.
This one. Tangential speed of light is, okay, here he has given the diagram. So they are moving in different radii. Okay, so the tangential speed of lighter stone is mv. Okay, and so the centripetal forces are same. So from that you will get a value of n.
Okay.
Centripetal force is mv square by r. So I would put the corresponding masses and corresponding radius and corresponding velocity.
N is 2.
Okay, one end of the string of length L is connected to a particle of mass m, and then is connected to a small plane on smooth horizontal table. If the particle moves in a circle with v, speed v, okay, the net force in the particle directed towards the center will be, okay, I am assuming v is not changing, speed is not changing. Okay, it's smooth horizontal table. Okay, so the net force in the particle will be, right. This is also a simple question. Got the answer? This is like
That is centrifugal force.
centrifugal force is a pseudo force.
And that will give tension of the string.
This is a theoretical question. Okay, centrifugal force is not a real force, it's a pseudo force. So the only force is the tension. Tension is the one which is providing the net force in the particles because of the tension only.
Yes, sir.
Okay, for example, in a straight line motion, so this is the surface and I have a mass m. Okay, and it is moving with an acceleration v, and I'm applying a force CF. Okay, so the net force, hold on, mass m, let it move, acceleration. Okay, the net force on this is F only, but I can remove this acceleration and put a pseudo force like this. That does not mean the net force is F minus m into E. This is not correct. The net force is F only.
Yes, sir.
Same thing here, that centrifugal force pseudo force is actually a centripetal acceleration. So for the force, we just have to input the tension. Only the tension. Okay, the string will be when the tension is more than 25 Newton. What is the maximum speed with the ball can be moved? Yeah, this one is also very simple. So the only force acting on this mass is the tension.
Yes, sir.
That should be equal to the mass into acceleration. Acceleration is the centripetal acceleration. Okay, so this tension will keep on increasing if V is increasing. R is fixed. Okay, so when tension becomes maximum tension, that is 25. So we have to find the corresponding B. What is the answer?
14 also. 14 14s are 196.
Yeah, 14. This one, coins plus distance are. Okay. You understood this question?
No, sir.
So the gramophone record is a platform, no? Circular platform. Okay. And the coin is placed on this platform. Okay. So what are the forces acting on this platform? Sorry, acting on the coin. And in the vertical direction, there will be weight and the normal direction. Okay. So that is not a thing. But in the horizontal direction, there will be only one force, that is a friction force, right? When this is, your mic is off.
Yes, sir.
There is only one force because when the platform is rotating, this mass will try to move out. Okay, so to avoid that moving out, the friction force will act in the opposite direction. So on the coin, the horizontal direction, there is only one force, is the friction force. Okay, so because of that, there will be a centripetal acceleration, or we can consider this. We remove the centripetal acceleration and put a centrifugal force this way, and this is pseudo force. So both have to be equal for it to remain in this particular radius. Okay, and actually this friction force is a variable force, right? We can go from 0 up to a maximum, and then it will go like this kinetic friction. So it can go from here to here. So this will give me a range of angular speeds. Okay, so omega should, for the limiting value, will correspond to the limiting friction. Okay, now we can solve the problem. Do it now. So the friction force should balance mv square by, okay, in terms of omega, right? So mv square by r is same as m omega square into r. So in the limiting case, this will be mu to the normal reaction, and normal reaction is mg. So mu g equal to omega square r. So omega is square root of mu g by r, and this is the maximum omega, and omega can be less than this one. So less than or equal to square root of mu g by r. So okay, omega is fixed, so radius has to be less than or equal to mu g by omega square. Is it clear? Done? Got it? Shall we move to the next one? Done? Your mic is off. Your mic is off. And unmute your mic. Unmute your mic. So got it? This thing clear now? Your voice is very low.
Sir,
Your voice is very low. So this is clear or not?
no, your voice is not audible.
You are changing something. You changed something.
No, I didn't do anything.
Network is bad or something. So is it clear now? This is your voice is not clear.
What is the difference UD equal to omega square R?
There is only one force acting on this coin, right? This is friction force. Okay, and this friction force is a variable force. So as and this is m omega square r, right? So suppose if omega is constant, so if r keeps on increasing, the friction force will keep on increasing, right?
R will be constant only.
No. R is a variable. R we can change. But the coin split distance r from the center. This is a range of r we have to find. No, look at the options. R is this one. R is less than. So r can be some particular value, but it can be value in a particular range also. Okay. So for a given omega, looking at the options, you can find out. You have to find r, no? So what is the value of r? So r can have a range. Omega is fixed because on the right hand side we have omega. So omega naught is fixed. So for a fixed m omega, if r increases, the friction force will increase, but it will increase up to your limit only. So when you put this limiting value of this friction, I'll get the maximum value of r. So that maximum value of r is square root of mu g by omega square. Okay, so
Normal is MD only.
yeah, normal action is mg only, and m will cancel with this m here, this m.
Okay.
Okay, so and this is the maximum friction force. So if friction is less than that, r can be less than that. So r can be omega square by g and also less than that. So the maximum r, the friction force will be maximum limiting value. So if r is less than that, the friction force will decrease to match this.
So why not omega less than or equal to? Sorry, omega is fixed value.
No, this is not required. This is not required. R is less than or equal to this one.
Okay.
This is the limiting value of R. So R can be less than that because friction, when R is maximum, friction is maximum. When if R is decreasing, this friction value will decrease less than the limiting value. It will come here. R can also be 0 because the friction force will be 0. So R can vary from 0 to a maximum value. Done?
Okay. What if R is greater than that value, sir?
It will start slipping. The friction force will be less. Centrifugal force will be more. So it will slip. It will move outside.
Okay.
It will start slipping and it will move outwards. Because centrifugal force is more than the friction force, maximum value of the friction force. So you'll start moving outside. Okay. Your mic is off. You change something, suddenly your voice level has gone down. You changed something. I can't hear you.
Before it was a computer speaker, laptop speaker. Now it is headset speaker.
No, now it's not auto. It's very low.
Now is it fine, sir?
No.
Now, sir.
Yeah, now it's
Is it
okay.
fine?
Yeah, now it is fine. So
Yes. So laptop microphone works better, I guess.
so don't change it. No, it's working. Why do you want to change it?
Okay, sir.
Okay, in this circular motion. So what is the complicated part? You were saying circular motion is a little bit difficult, no?
Yes, sir. More difficult questions. I will send you WhatsApp, sir.
Okay, see the most complicated question in this circular motion is this one. This one, right?
These are from Newton's law of motion.
Yeah, but this is circular motion.
Yes, sir.
And another difficult thing in circular motion is this vertical circular motion.
Yes, sir.
Okay, so this also, I mean, the concepts are not complicated. See, compared to the horizontal circular motion, here the tension in the string, will it be same or it will change with time? See, this is horizontal circular motion, right?
Yes, sir.
Okay, because this circle is horizontal. Okay.
Yes, sir.
The tension in the string, is it constant or changing?
It changes with theta, no, sir.
With theta it will change, but for a given theta, this thing is fixed. So for that, tension is constant once theta is fixed.
Okay.
Okay. Theta is fixed, the length is fixed. Okay, so the tension is remain constant, but in the vertical circular motion, the tension will keep changing, right? Your mic is off.
Yes, sir.
And where is the tension maximum?
At that bottommost or topmost.
Topmost, the tension will be minimum. Because tension, see, weight is always acting downwards. Okay, and centrifugal force is mv square by r. So that is in radial direction. When it is downwards, so it will add to the weight. So both weight and centrifugal force will add, but when it is at the top, weight and centrifugal force are in the opposite direction. Okay, so they will separate. Okay.
Yes, sir.
And the remaining will contribute to the tension. So the tension is minimum here, maximum at the bottom. Okay, in between it will be little bit less because mv square by r, I have to take only the component.
Yes, sir.
mv square by r downwards, but mg, I'll take a component of mg along this string direction. Okay, for example, at this position, mg is vertically downwards, and theta is the angle between vertical and the string. So this angle is also between the vertical and the string direction. So it's the same theta. So mg cos theta. So tension is mv square by r plus mg cos theta. And this mg
Yes,
cos theta
sir.
will keep on. And also, g is also decreasing as you go up. As you go up, the speed will keep on decreasing. How do you understand that one?
potential energy increases, so kinetic energy will decrease. So
yeah, because there's no other form of energy. So
yes, sir.
so tension. So since the tension here is mv square by r minus mg, so both tension will decrease because the centrifugal force decreasing, and also the component of weight decreasing or opposing the centrifugal force. So the tension can become zero here also, somewhere in between also, depending on the value of the velocity. Okay, so
Yes, sir.
So it's basically only three cases are there. If the velocity, see the initial condition, the initial velocity give at this point.
Yes, sir.
Okay, there is, because other things are fixed. Length of the string is fixed, the mass of the whatever sphere or whatever is fixed, gravity is fixed, everything is fixed. The only thing you can change is this initial speed. So depending on the initial speed, there are three cases. One thing is it will go up to this thing and then it will come back and it'll keep on going like this, like a pendulum. Okay. Another option is it can go up to here, okay, and then it will drop down. Okay. When it's going to drop down, the tension will become zero. Tension is going to become zero here. Okay, but if the tension is there and if the velocity becomes zero at this point, then it will not fall like this. It will keep oscillating like this.
Yes, sir.
So here there are two possibilities: whether the tension becomes zero first or the velocity becomes zero. If the velocity becomes zero, then it will keep on oscillating. But if the tension becomes zero, it will fall like a projectile because the thing is free to move. Another thing is if the velocity is sufficiently large, then at this point both tension is present and also velocity is non-zero. So once it reaches maximum point, it will keep continuing. So there it will keep on doing the circular motion. So these are the three possibilities, or we can say four. One is the lower circle, lower half, and here there are two possibilities: whether tension becomes zero or velocity becomes zero. And if it covers, if it reaches the topmost point with non-zero tension and non-zero velocity, it will keep on continuing.
So, what is the condition for the particle to oscillate in lower circle, sir?
See, once the velocity becomes zero here, it will
Okay, here it's a.
It will not go
Yes,
up,
sir.
but the tension is there.
Yes.
So it will return back. So this is a concept of a simple pendulum.
Yes, sir.
Simple pendulum, it's less than a semicircle. So as soon as it reaches this point where the velocity becomes zero, it will return back.
Yes, sir.
Okay, so that turning back can also happen here if the tension is still alive. Okay. So we have to find whether the tension becomes zero first or the velocity becomes zero first. So if tension becomes zero first, sorry, the velocity becomes zero first, then it will oscillate. Otherwise, it will.
So at topmost point only velocity will become zero, no, sir. All energy will be converted to that potential energy.
If the topmost point velocity, no, not necessarily. This initial, see, if the velocity becomes zero here, that will correspond to a particular initial velocity, right? Now I increase the velocity beyond that value. Then the velocity which reaches the topmost point will be non-zero. It's not like a ball which is thrown from the ground, which goes to the maximum height and returns back. So here the velocity has to be zero. This is the turning point. But here it's not like that because the string will pull it back, even if the velocity is not zero. Because this radius cannot, the length of the string cannot go more than that. No, it will pull it down. But here in the case of ball being thrown from the ground at the maximum height point, the velocity has to be zero. But here the velocity will not be zero. Even if the velocity is not zero, it cannot go up because the length of the string is fixed. So when it goes this way, it will try to pull it down. Is it clear?
Yes, sir.
So the velocity here need not be zero. So these are the two difficult topics, I think, from in the circular motion. One is this one. This we have to find. So here in this car moving on a, you know what this road is called?
Banked road.
So basically, I'm making it as sort of an inclined plane. Okay. So when the car is moving like this, so what is the direction of friction force?
Opposite of that centrifugal force, sir.
Centrifugal force will be outward or inward.
Outward.
So this is centrifugal force, no?
Yes, sir.
Okay, let me call it FC. So the direction of friction force is this way, is it?
Yes, sir.
Okay. Suppose if the car is going very, very slow, then what will happen to this friction force?
It will reduce.
Yeah.
Decrease.
What about the direction? See, there is a, see mg, it's vertical, no? So mg, the component of mg this way is how much? Mg sine theta.
Yes, sir.
And what about component of the normal reaction? So this is mg sine theta, and normal reaction is normal to the surface. So it will not contribute to the, so I'm basically resolving the forces along the plane and perpendicular plane. So normal reaction is perpendicular to the plane. So there will be any component of this along this surface. So along the surface, there are two forces. No? One is mg sine theta downwards, and one is centrifugal force, which is mv squared by r. So when the speed is very, very low, this thing will dominate. Mg sine theta will dominate. Okay, so the net force will be in the downward direction. So in that case, what is the direction of friction force?
Will be outward.
Yeah, so that's also an important concept to understand. So the direction of friction force is also changing. Okay, when the speed is very low, the car will try to slide down. It's like a mass on an inclined plane, right?
Yes, sir.
The block of mass kept on an inclined plane will slide down. No, that's because of the weight component. So same thing is happening here. Because of this mg sine theta will slide down. So when the speed is very, very low, this friction force will be in the opposite direction. So velocity and this, just assume this limiting case, just assume extreme case where this centrifugal force is almost zero. So if this mg sine theta is greater than the limiting friction force, then what will happen?
Then kinetic friction will.
No, kinetic friction also. It's kinetic friction is less than limiting friction. No.
Then the car will slip, sir.
Yeah, so car will slip. So for the car to remain on this circular whatever path, so this velocity should be greater than v minimum. It cannot be too small also, and greater than some v max. V
Yes,
max
sir.
condition will correspond to this one. Friction force in this direction, centrifugal force in this direction. So that thing will correspond to Fc minus mg sine theta, where is the net outward force. That should be less than F limiting.
Yes, sir.
So this will give me V max.
Yes, sir.
Okay. Similarly, mg sine theta minus Fc. Okay. This is the net downward force. So this should be less than F limiting. Okay. So this will give me what?
Minimum V.
Yeah, V min. Because here it's minus V square, no? Here is plus V square.
Yes.
So V square value is, if I take this thing on that side, I'll get V square is less than something, so V is less than something. So V less than something means I'm getting information about V max. Here it's minus, so I can take it on that other side. So V should be greater than something. So that will give me information about V min. Is that clear?
Yes.
This is V minus V square by R, no? So I can take it on the other side. So V square is greater than something. So that means V is greater than something. So V greater than something means it will give me information about V minimum.
Yes, sir.
So this is the most complicated situation you can have in this banking of roads. So yeah, so the direction of the friction force is also variable, depending on whether there are two forces acting on this vehicle along the plane. One is mg sin theta, other one is centrifugal FC. So whichever is dominating, it will slide in that, try to move in that direction. So the friction is the opposite to that. So when velocity is very low, mg sin theta will dominate. So in the limiting case, mg sin theta minus fc should be equal to the f limiting. That will give me minimum velocity. And when this car is moving at high speed, fc will dominate. So fc minus mg sin theta will be the net force acting outwards. So the friction force will be in the opposite direction. So the limiting case, fc minus mg sin theta should be equal to f limiting. So that will give the maximum velocity. So as far as circular motion is concerned, this is one complicated concept. Okay, and this conical pendulum, it's a horizontal motion, and once theta is fixed, it's a uniform circular motion, and tension is constant. And this vertical solution, there are three cases. This is one complicated concept. And in addition to that, here you can have a mass inside sort of a drum. Okay, so when you rotate this drum, what will happen to this mass? Will it move?
Where is that mass, sir?
Here, this small sort of a block or a sphere, whatever you can take. Some mass is here. Okay, so this is inside of a drum. So the forces acting on this mass is clear. Now, what is the weight? Okay, normal direction, normal to the surface. That will be the radial direction. And then what is F?
Friction.
Yeah, F is friction force because of this weight, it will try to slip down. Okay, so friction will try to opposite. Okay, there is no motion in the horizontal direction or in the radial direction because this way you cannot pierce the wall and come out because the wall, the drum will stop it, and inside it will not move because it will not move inside. Why it will not move inside? Because in a circular motion, when if it is just left to itself, it will try to move tangentially, right? If it tries to move
Yes.
tangentially, it will hit the wall. It will not move inside. So in a circular motion, there's nothing stopping it. It will just move away tangentially. Okay, so when this mass, if it tries to move away tangentially, it will hit the wall of the drum.
Yes, sir.
So that's what is contributing to the normal reaction. Okay, so these are the forces acting on this mass. So when it's so what is the condition for it to? So is there a limit on this velocity for it to move like this? What will happen if the velocity is too low? Will it fall down?
Yes, sir.
Why will it fall down? So what is the minimum velocity?
That I don't know, sir.
So you just have to see this friction force is a variable force, no?
Yes, sir.
So we can say mg should be less than the F limiting. If it is more than F limiting, it will fall down, right?
Yes, sir.
Okay, so this and also this normal reaction. So this F limiting is mu into normal reaction. What is normal reaction?
Pseudo force.
Yeah,
Sorry, centimeter.
mv square by r. So velocity should be, so from this I'll get velocity should be greater than gr by mu. Is that right?
Yes, sir.
And if velocity is greater than, so as long as velocity is greater than that, it is fine. It will remain in this circular motion itself. Okay, but here it was not like that. There was a range of velocity. Velocity should be greater than v minimum and also less than v maximum. If the velocity is too high, it will move away. Okay, if the velocity is too low, it will slip down. So here in this case, the velocity should be between a particular range. But here, there is no limit on the maximum velocity. Only there is limit on the minimum velocity. So the minimum velocity is square root of g r by mu, but maximum velocity can be anything. It can be infinite. But in reality, if it goes very, very large, this drum will break because normal reaction is mv square by r. No, the drum has got a particular strength. Okay, but given problem like this, there is no limit on the maximum velocity. There is only limit on the minimum velocity. So next time I'll solve some problems on that based on this, so that will become clear.
Yes, sir.
Understanding theory is fine, but after that you have to solve problems. Only then you will remember. So what I wanted to say is the complication in this circular motion are only these things. One is
Yes,
this
sir.
one. This is a simple one. There is no here. There is a minimum velocity. Velocity should be greater than that. Here there are three cases. Okay, so here you have to find the tension as a function of theta. Okay, here
Those, sir, that derivations and all.
yeah. So basically there will be two equations. You have to write equations in two directions. One is horizontal and one is vertical. And you have to put the condition that t is greater than 0 and the velocity is greater than 0. These are the two basic concepts. So based on this, we'll get all the conditions.
Okay, sir.
Okay, so if u is greater than some, okay, these two will give me some information about the u at the lowest point. Okay, for this to happen, u should be of some value. Okay, it will turn out that if u is between 0 and √2 gr, it will be less than this semicircle. Okay, and as you keep increasing this initial velocity, it will go at higher and higher points. So if u is greater than √2 gr and less than √5 gr, it will go up to here. And I think tension is becoming 0 before u becoming 0, velocity becoming 0. So when that happens, it will become a projectile motion. Because here the tension is becoming 0. So after that, with this initial velocity, it will move as a projectile motion. Okay, and if velocity is greater than √5 gr, then it will complete the circle. It will keep going in circle, round and round, but it's not a uniform circular motion. Okay, so I think this thing you have to remember: √5 gr, and then less than √5 gr up to √2 gr. It will be in the more than half circle. Actually, when it goes above the half circle, the tension is becoming 0. So it will become a projectile after this point, and what is less than √2 gr, it will be less than half circle. It will be like a simple pendulum. But for NEET,
Yes,
I don't think the question should be complicated. The complicated case is this one. This one where it is become projectile motion here. So most probably this will not come for NEET. Okay, so only this will come. where it is going to complete this full circle, and where it is less than half circle. Only these two are the simple cases. So most probably problems will be based on those two conditions. Okay, so tomorrow I'll solve some problems based on this.
Okay, sir.
And circular motion. Okay. The radius of a circle, P of revolution is position revolution indicated in the figure. Y projection of radius vector. Okay, this is basic concept. Can you read the question? Try this one. This is actually
Sir, I don't know, sir.
It's
I
actually
forgot this concept.
no. This is very basic. It's a mathematical concept only. See, radius of circle is given, no? It's 3 meters. Period of revolution, it's given 4 seconds. Initial position and sense of revolution. So it's rotating clockwise direction, and p t equal to 0. Okay, this the projection of y. Okay, so basically this is the radius vector, no?
Yes, sir.
And what is projection on y-axis? Let this be the initial position. I think he has not mentioned it clearly. This is the initial position, p at time t equal to 0. So this angle theta is going to change, increase, no, with time.
Yes, sir.
So that you have to, so basically you have to get so y is function of theta, right?
Yes, sir.
So what is y in terms of r and theta? R cos theta, is it correct?
Yes, sir.
Okay, and r is constant, theta is going to change. Okay, and what is theta? Omega t, right?
Yes, sir.
And omega is what?
2 pi by t.
2 pi by 4 cos, and r is what? 3. So this is the answer. So plus and minus sign is confusing. Okay, so basically initial time, which is the first quadrant, okay, where the projection of y is positive, cos is positive in the first quadrant, and this cos is like this, no? Second quadrant,
First,
third quadrant is this one, and the fourth quadrant. So first quadrant it is positive.
yes, sir.
So I think this is the one. 22 is 4. Right? Is it clear?
Yes, sir.
So this is basically theoretical question, so it's not a NEET question. Okay. So just for getting the concept clear.
It is in oscillation only, no, sir.
No. This is
Oscillation.
there is no oscillation here. There, he's
Oh.
not even mentioned gravity is here and all. Okay, this can be a horizontal circle also. Okay, and also it's a he has not mentioned it's uniform, but since it's period of revolution, here I put theta to omega t, no? So I have
Yes, sir.
assumed it's uniform circular motion.
So for except t, that expression, can you please write that, please?
What?
We have found y of t, no, sir. Function is y.
Yeah, but the assumption is made no here. Theta to omega t means it's uniform circular motion.
Okay. Can you please write in terms of x, sir? X of t equal to that expression.
No, yeah. He's asking y projection. No, why do you want x?
I'm just asking, sir,
Yeah, you can write
how
x.
to do.
You can also write the x projection. Suppose he says the x projection. So x is r sine theta.
Yes, sir. And in terms of cos means then 90 minus theta, no, sir?
Yeah, you do not do those things. See, once I fix this as theta, okay, x is sine theta only. Y is cos theta. I'm fixing this as theta, no, because the particle is starting from here. This is my initial
Yes, sir.
position, and I'm measuring the theta from the initial position. So I have to measure theta like this only. So when I fix this as theta, y is cos theta, and x will be sine theta.
Okay, sir.
I cannot change that. Okay, this is not a NEET question. Okay, so don't. This is just for basic getting the concept clear.
These set of questions they have asked us.
No. See, this is NEET. Okay, question number 19, 18, and from 20, these are not NEET questions. They are just coaching institute questions. Okay, so this is just for getting the concept clear. So there is some ambiguity, right? So those things won't be there in the actual exam question. This basically get the concept clear.
Okay.
So this one is block of mass terminals, contact the inner wall of a hollow drum. Yeah, this one I just discussed. Try this one. This is very simple. I just told a concept, right? This is the concept you have to use in this question. So there is a limiting value for the minimum velocity. Okay, maximum velocity can be anything. So you have to find the minimum velocity.
Question, please, sir.
Yeah, this one.
Ten, sir.
Option 3.
That is velocity. Okay. R omega will be by 10 only, sir.
So option 3.
Yes, sir.
Yes. So in the minimum velocity case, the friction force should balance the weight, right?
Yes, sir.
It should balance the weight, so mg. And this friction force is the limiting friction. So mu into the normal reaction, which is mv squared by r. V is given, so you can find this one, two particles are moving into. Okay, this we already did. Okay, one is connected to a mass in, and the other is connected to a small particle. Okay, this also you've done. the particle conversion. Okay. Yeah, try this one. What is the initial velocity of this particle?
75, sir.
Omega I, initial velocity,
0.
because it says it starts.
Yes,
Okay.
sir.
So read the question carefully also. So basically, the total, okay, it's a time interval. So some theta 2 minus theta 1 is 100 radian. Okay, and theta 2 is half at square, right?
Yes,
So
sir.
half alpha t2 square minus t1 square equal to this much. Finding the time interval surrounding. Basically, you have to find. Okay, t2 minus t1 is known. Fine. Delta t is 5 seconds. Alpha is given. Did you solve it?
No, sir. I'm writing
Okay, so
root 3. Root 3 5, sir.
so alpha is how much? 2, right? So t2 minus t1 is 5 into t2 plus t1 equal to 100, right? So t1 plus t2 is 20 and t2 minus t1 is 5. So from this I have to find, so I'll subtract these two. So I'll get 2 t1 equal to 15, t1 is 7.5. Yes. It's a little bit complicated, but if your thinking is clear, then you can solve it. The first thing is you have to write these steps. Otherwise, okay, alpha is 2, theta is 100. I calculate delta theta in a particular interval. Then the corresponding time interval is 5 seconds. In the time interval of, so it doesn't say when the, but the initial is the thing which is corresponding to the time t equal to 0. So theta 2 minus theta 1 is 100. So since the initial thing is 0, I can use ut plus half at square in the corresponding angular equation. So half at square. So half alpha t square. So t2 minus t1 is 5. So from that I can t1 plus t2 is this one. And already I know that t2 minus t1 is 5. So I have two equations at two moments and I have to find t1. So I'll subtract these two. Is it clear?
Yes, sir.
Okay, we'll stop now.
Okay, sir.
So Fine. So any other question? Any doubts?
No, sir. Thank you, sir.